Hello everyone, in this video I'll be solving the problem Symmetric Tree, and this problem is from Geek for Geeks, and it says given the root of a binary tree, check whether it is symmetric, that is whether the tree is a mirror image of itself. As you can see from here, one is there, and if you try to draw a line here, so 4's mirror is here, 4, 2's mirror is here, and 3's mirror in this way. So you'll have to find the symmetric way, symmetric mirror image basically. If you try to draw a line here, so this is not the symmetric mirror. Let's go, a binary tree is symmetric if the left subtree is a mirror reflection of the right subtree. So let me take this problem and try to understand on the board. So first problem they've given is they've given a tree 1, 2, 3, 4. 3, and this is 4. This is also 2. This is 4, and this is 3. So if you try to draw a line, also you can put it here mirror. So 4 will appear at this position, 2's right in this position, 2's right is 4, but in this position 2's left is 4. So right and left both will be mirrored. Here if you see 2's left is 3, here 2's right is 3. Here 1's left is 2, here 1's right is 2. So how can we solve this problem? It's easy only, not that hard, but if you try to observe something, the number of nodes in this tree has to be odd number of nodes has to be. Why do I say that? Because see, this 1 will not come into picture in left subtree or right subtree. This is a common, so we have one node, and let's say now this left subtree has, let's say, x number of nodes, okay, and plus then let's say to be a mirror image of left subtree, the right subtree, so it has to be that many nodes only. So x has to be, like in both the left and right subtree, the nodes has to be x only, so that a mirror image is possible, or else not. So if you try to do this mathematically, 2x plus 1, let's say x is anything, but 2x will give this even number, and this is 1 basically, which is odd number. So as we know, even plus odd will always result in odd number. So first thing is that whenever the number of nodes in this subtree, I mean in this tree, is even, in that case mirror image is not, symmetric is not possible basically. Yeah, and one observation is that. Second observation is, let's try to take this down. So one thing we can do is that, let's say we'll try to write the node values. If we try to write in order traversal, in order traversal is basically left, root node, and right, which means first we'll have to go to left node, we came here, we'll have to go to left node, we came here, we'll have to go to left node, that is nothing, we'll have to return. Now we'll have to consider root, whose value is 3. We'll go to right node, we don't have anything, we'll come back, we'll go to back, this is the root what we will be considering, which is 2, and we'll go to right. We had went to left, we considered root, now we'll go to right. Similar thing we'll do, left nothing is there, root which is 4, right nothing is there, we'll come back, from here we'll come back, left we have considered, now root will consider. Now left consider, root consider, we'll go to right. Once you came here, we'll go to left, once you came here, we'll go to left, which does not have anything, we'll come back, we'll consider root, we'll consider, we'll go to right, we don't have anything, we'll come back, again we'll come back here, left we have considered, now we'll consider root, which is 2. So we'll go to right, it does not have any left, it has root which is 3, it does not have any right, we'll return, and we'll return. So this is basically the in order traversal. This is in order traversal of the tree. Now if you see here, this is basically our root node, okay. So in order to be this mirror image of this one, or right subtree to be a mirror image of left subtree, So in the in order traversal also, from the mid element, both the left and right elements has to be equal. As you can see, this is at distance 1 which are equal, this is at distance 2 which are equal, this 3 is distance 3 which are equal. So the in order traversal also has to be equal from the middle element if you go to 1 index apart from this middle element. So this is the second observation. So this is our answer basically. We'll try to find the in order traversal, and as we know, like this will be having x number of elements, right will have x number of elements, and root is basically 1. So in order traversal, all these values will come before this node value. So we'll try, this is basically the mid value what I'm trying to say. So we'll go to the mid value, that will be length of the in order traversal, which is 7 by 2. If you do this, will give you answer 3 in integer division. So if you try to consider 0 1 2 3 4 5 6 as an array element which starts index 0, so this is the middle element which comes out to be at 3. Now we'll take left pointer, we'll take right pointer, one from middle we'll take one less, from middle we'll take one right as a left and right respectively, and we'll try to compare. If any point these two values are not equal, then in that case we don't have any symmetric tree. If all the elements are equal and we and left points to out of bound and right also points to out of bound, then in that case all the elements were equal and then we are returning true. So let's try to again understand second example which will give us clear picture. So first observation was that the number of nodes has to be odd, 1 2 3 1 2 3. Let me take second example. We have 1 here, this is 2 and this is 3. We have 2 here, this is 3. Now again we'll do in order traversal. In order traversal, I think you guys know how to do it. Let me do it one more time. From root we'll go to left, from left will this is now root, we'll go to left, we don't have anything, we'll consider root. This is in order traversal. So 2 we have considered. Now we'll go to right, left is not there, we'll consider root, we'll go to right, nothing is there, we'll come back, we'll come to this which is root. We'll go to right, since we have considered left, we'll go to right, we'll go to left, nothing is there, we'll consider root, we'll go to right. And yeah, this is our in order traversal now. And if you try to see, the length of the in order traversal is 5, which is odd. So our first condition meets, which means it is possible that this tree is a symmetric tree. So one thing is clear. Now second thing we'll have to look into is that we'll have to find the middle element, which is 5 by 2 will give you 3. So 0th index first, second 3 4. This is not 5 by 2 3, this will give you 2. Because in integer the if you see, this is actually 2.5, but in integer this 0.5 will be erased, will not be considered. So here we have 3. Our mid is pointing at this point, left will point less than 1 mid, right will point 1 less than, 1 greater than mid. Now in this position, if you see, like basically when there is odd, so both the elements on the left and right has to be equal only. Okay, so what I'm trying to say is that now we'll have to consider left and right, we'll check the values which has 3 2 which are not equal, so which means it is not a mirror image, as you can clearly see from the diagram also. So 1 is okay, good, 1's left is 2 and here 1's right is 2, which are mirror image, but 2's right is 2 in this case, and here also 2's right is 3 in this case. But if it were like something like this, then it would have been a mirror image. Okay, but now if we have on the right side and here also we have on the left side, so it is not a mirror image, which we can see clearly from the in order traversal. Okay, so I think pretty much you got what we'll have to do. We'll have to first find the in order traversal, and we'll try to find the these things. From the middle we'll go to left and right and we'll compare the values. If both are equal, fine, or else it is not fine. Now one case I am considering here is that in my mind I'm getting right now. So let's say here we have a value 4. Okay, so in that case our in order traversal will be, let me erase so that you guys can get some clear picture. So 4 will get here, which is an index 5, but its size is 6, so which is even, which means will return false, which is true. If Since this is not a symmetric, we are writing false. Let me add one more node, let's say 5. If you are adding one more node 5, this is the in order traversal, which is 6th index. So in this case the length is 7 by 2, which comes out to be 3. Okay, so this is our middle element. Okay, middle element, but yeah, in this case again, if you try to compare left and right, 1 not equals to 3, so this will give you a wrong answer only. Got it? So yeah, basically this method works, what I'm trying to say. And also if you can see from the picture, this is not a symmetric. So let me try to code it up. So what we are finding the in order traversal. We'll take vector int in order, we'll take one in order function in order, we'll pass the root and we'll pass this in order vector. Now let's go to define the in order. It is taking root, it is taking vector of in order. Let's pass it by reference so that whatever edit you do, it remains persistent. So if root equals to null, which means we came out of like left or right side, we came out of root node which is null. In that case we'll have to return simply. In order means first time we'll have to go to left side, we are passing this vector. Now next time we'll have to go to right side also. This is where once we consider the root node, so we'll consider root node. Basically roots node data will be storing in order, and once we store we'll go to the right node. So this will give the in order traversal. Now what we'll find is we'll get this n, which is basically the size of the in order. Yeah, in order's length whatever is there, if n modulo 2 equals to 0, which means it has even number, so in that case will return false. As I showed in board example, like it was 2x plus 1, so it is always odd if we have even number, so in that case there is no symmetric. Now we'll consider mid as n by 2, we'll consider left as mid minus 1, we'll consider right as mid plus 1. Got it? So now we'll take a loop. It should be left greater than equals to 0 and right less than n, which is where considering the boundary cases, so it shouldn't go beyond boundary. Once it goes beyond boundary, which means all the elements were equal, we'll have to return false. So once we come out of the boundary, which means all the elements were equal, we'll have to return true, which means it is symmetric node, symmetric tree. Now what we are trying to do is we are comparing left and right. If in order of left not equals to in order of right, which means the symmetric element is not there. Like left subtree and right subtree does not have a similar kind of node, so in that case we will return false. Now let's say if both were equal, so we'll try to move to the next numbers. We'll compare the next greater numbers. We'll expand the we'll move to from middle, we'll move to outwards. Let's try to run the code. It is running fine. Let's try to submit the code. Yeah, it got accepted. So this was pretty much. Now let's try to understand the time complexity. We are doing this in order function. Let's go here in order function. In order, we will be driving to each and every node. So if we consider n as the number of nodes, so this function will take O of n, and this is a loop which will take n by 2 because we are starting from middle and moving at a time or one distance apart from middle. So this will take n by 2. So basically time complexity is O of n only, and since we are using a vector to store the in-order traversal, which will store all the values of tree, all each nodes, so this is also taking O of n. So here both time and space complexity are linear. So yeah, thank you guys for watching the video.